Welcome to this explainer. I am absolutely thrilled you're joining us today. We're diving into a really specific, high-stakes engineering briefing, the engineer's guide to busway selection, or, as it's often thought of in the industry, the core checklist for engineers, that 工程师选购母线的核心清单 when procuring busways. We are going to completely dismantle a pretty dangerous industry misconception today, and then we'll replace it with a rigorous, reliable framework that you can actually use in your procurement process. If you're designing industrial or commercial projects, this is exactly what you need to make sure your systems are safe, scalable, and, fully verified. Let's get into it.
So let's kick things off by asking a really critical question about a shortcut. I mean, let's be honest, it's a shortcut a lot of us have been tempted to take. When you're sizing a busway, have you ever just calculated the load current and then immediately jumped to the next standard catalog size? It's common practice, right? It feels super efficient in the moment. But the real question is that actually enough to guarantee system safety and performance? Spoiler alert, no. It is absolutely not enough. In fact, that shortcut is a massive risk. It completely ignores some vital operational variables. Just because a route passes a basic ampere check, well, that doesn't magically mean it's safe. It can end up running dangerously hot, it can leave you with literally zero margin for future facility expansion, and honestly, probably the most immediately frustrating thing for an engineer, it can cause your submittal review to just fail entirely. So here is our roadmap for today's briefing. We're going to cover 1. Busway selection pitfalls. 2. The 3 core currents. 3. Temporize and performance. 4. Environmental derating factors. 5. Our core procurement checklist. And finally, number 6. Manufacturing and standards.
Okay, starting with Section 1, busway selection pitfalls. Specifically, we're looking at the real danger of that standard size shortcut we just talked about.
Look, if you're only looking at the amperes and just rounding up, you are essentially flying blind out there. You're risking severe overheating during peak operation, plus you are baking exactly zero expansion margin into your design. That means the very second the client adds a new piece of equipment, boom, the system is maxed out. And from a project management standpoint, you're practically guaranteeing a rejected submittal, which, let's face it, is nobody's idea of a good Tuesday. And why does this happen? Because a simple, basic ampere check totally ignores critical interconnected requirements, things like temperature thresholds, fault level tolerance, and voltage drop limits. All of those have to be verified together as a complete package. Moving right along to Section 2, 3 core currents. We really need to break down the load here. Now, according to engineering best practices, there's this vital rule of 3. As an engineer, you need to deliberately separate 3 distinct current values before you even think about choosing a rating. First up, you have your connected current. That accounts for every single thing physically tied to the system. Second is your operating current, which represents what's actually running dynamically on a day-to-day basis. And finally, step 3, the selection current. If you mix these 3 up or treat them as the same thing, your entire baseline is basically flawed from day one. The real secret sauce here is isolating that final one, the selection current. This right here is your ultimate, fully verified metric. It acts as your true, rock-solid baseline. You absolutely do not procure equipment based on the raw connected load. Instead, you procure based on this carefully isolated selection current, because that is the number that accounts for the reality of the system's actual operational demands. All right, Section 3, Temporize and Performance. This is where we compare nominal ratings against real-world reality.
Here's a somewhat wild truth about those labels. A standard nominal ampere rating, the simple number printed right there on the label, it really doesn't tell the whole story at all. You can have 2 busways with the exact same nominal rating, and they can behave entirely differently under the exact same load. One might stay perfectly cool, doing its job, while the other is practically melting down and approaching its thermal limits. Why does that happen? Because the internal design and the actual material quality vary wildly between manufacturers. Because of that, temperature rise evidence is your only real source of truth. It's way more important than whatever nominal label is slapped on the side.
Let's jump to Section 4, environmental derating factors. We need to talk about modifying those numbers before you freeze your spec.
Listen, before you lock in that specification, you absolutely have to derate your selection based on a few key environmental modifiers. First, ambient temperature variations in the specific facility. Those can drastically alter how the system performs thermally. Second, the specific installation position matters immensely. I mean, is it mounted flat, on its edge, vertically? Heat is going to dissipate totally differently in every single one of those scenarios. And lastly, the total route length. You have to modify your baseline rating to account for these physical realities, because if you don't, your perfect textbook calculations are going to fail hard in the actual physical building.
Which brings us to Section 5, really the heart of our briefing today, the core procurement checklist. This is the engineer's ultimate defense. Now, if you take nothing else away from today, let it be this matrix. This checklist right here is the definitive selection framework that critical 工程选购目线的核心清单 for industrial and commercial projects. Let's walk through it. First, the load schedule. This establishes your highly accurate baselines. Second, verifying the short circuit withstand. This is totally non-negotiable, guys. It's what prevents catastrophic fault damage. Third, calculating voltage drop to ensure your end-of-line equipment actually functions properly when it's all flipped on. Fourth, tap-off planning. This guarantees you have that vital margin for future expansion we talked about earlier. And finally, test documentation. This verifies all those manufacturer performance claims, specifically those temperature rise claims we just went over. Neglecting even one, literally just one of these items, can turn what should be a routine installation into an incredibly expensive and dangerous disaster.
Finally, we're at Section 6, Manufacturing and Standards. We'll take a look at Xinma's compliance backing as an example.
So what does this level of rigor look like in the real world? Let's look at Xinma. That's Shanghai Xinma Busway and Cable Tray Co. Ltd. They manufacture intelligent cable management, seismic bracing, and busway solutions that are specifically designed for high-stakes, mission-critical environments. We are talking about massive data centers, complex rail transit systems, huge industrial plants, and commercial buildings. When you are dealing with applications like these, skipping any part of that procurement checklist we just looked at is simply not an option. The stakes are just way too high.
And let's tie this right back to our checklist. Remember that test documentation requirement we emphasized? Well, to satisfy that, Xinma's products are strictly backed by a really comprehensive list of standards. You've got international benchmarks like IEC 614396 and IEC 61537 right alongside NEMA VE1 and the national standard GB 31251. When a manufacturer can hand you documentation that is fully compliant with these standards, it proves without a doubt that their busways are going to behave under load exactly as they claim they will. And that is exactly how you mitigate the risks of overheating and catastrophic failure.
As we wrap up this explainer, I want to leave you with a bit of a provocative thought, something to really apply to your current and future projects. Think about the design sitting on your desk right now. If your current busway spec was comprehensively reviewed today by a third party, would it actually pass those interconnected temperature, fault, and voltage drop tests? Or did you just select the next standard size up? Just remember, separate your currents, apply your environmental re-rating factors, and always demand the test documentation. Stick to the checklist. Thank you so much for joining me for this explainer, and I really hope this helps you engineer your next project with absolute confidence.